So, dear students, I welcome you all to this class of physics, and I am your mentor Fardeen. So, today we will be discussing a very important and very interesting topic that we call as stationary wave or a standing wave. For your convenience, I have written the topic on the board above. Now, stationary wave looks a very surprising term. Standing wave looks a very surprising term because when we speak of wave, what comes to our mind is the continuous transport of energy across a medium. Yes, that is true. And the definition of a traveling wave is when energy is transported from one point to another without the actual movement or the bulk movement of matter. Transport of energy from one point to another without any bulk transport of matter. You can also say that while energy and momentum are transported across the medium, the particles are simply oscillating about their mean positions. So what actually happens is each particle goes on transferring energy to the next particle, and each particle copies the motion of the preceding particle. Now just imagine what happens when two waves traveling in opposite directions meet. So the result is very surprising, and that result is nothing but your stationary wave or the standing wave. So let us look at the two figures one by one which I have drawn on board for your convenience. In the first figure, you can see that there are three segments as if the three loops, and certain points I have marked as N and certain points I have marked as A. So there are 4 N's and 3 A's in this figure. These A's I am calling as antinodes and these N's I am calling as nodes. So in a stationary wave, just to state the facts first of all, nodes are the points which are permanently at rest. Yes, I said it right. Nodes are the points which are permanently at rest. Antinodes are the point where the amplitude is maximum. Where the amplitude is maximum. So that may sound a little confusing to you because amplitude itself means the maximum displacement from the mean position. Now, in a stationary wave, what happens is this particle goes up to this point and falls back to this point. So it goes up to this height and comes back to this point. But it's not the same for all the particles, because this particular particle, it goes only up to this point and comes back from here and then comes to this. So you can say that different particles are oscillating between different extremes. This particle oscillating, let us say, between these extremes, this particle oscillating between these extremes, and one particle is oscillating between these extremes. So this is the maximum amplitude. So these points have maximum amplitudes and these points are permanently at rest. So they are not moving at all. So this is very surprising how it happens. Yes, it happens because at these points there is a completely destructive interference and hence its displacement is zero at all the times. And here there is a perfectly constructive interference that is at the point of antinodes, these points. For other points, it's midway. So how are we going to actually understand it and contrast it with a traveling wave? So if you look at this particular figure, which I have drawn for a traveling wave, I have shown you one particular dark line, which you can say is the snapshot of this string at that particular moment of time. But after some time, the shape of the string will change, and there is this dotted line which I have drawn to you, and then there is the third dotted line. So if this is the shape at this moment, the shape would be different after some time. So it seems that this shape is traveling across the string. But what is actually happening is, now this particle, it was passing through its mean position at this time, and this particle was at its extreme position. So as the energy is transported, this particle starts coming down, this starts coming down, this starts coming down, this starts coming down, and you can see that this particle which was here, it has reached its extreme position now. So some particles are coming down and the others to their right, they are coming up also, and one particular point, this point is at rest. So here all the particles are in continuous motion, no particle is permanently at rest. So it seems like in this shape, like these points somewhat look similar to these points, but they are not, because this particle will go down, and this particle will go up, and after some time will reach this position. The same thing is being done by each particle after some time lag. But in a stationary wave, what I have said is these points are permanently at rest and we call them as nodes. So here, because there is no interference, it is a traveling wave. Here there is an interference of the waves coming from the opposite directions, and because of the interference the result ensues. Now what are the other differences? So as I said to you, like if I remind you the equation of a traveling wave which is moving, the equation is something like this: a sine omega t minus kx plus phi being the phase constant, and here this term represents the amplitude of this traveling wave. So each particle, it goes up to the same height and comes back. Just pay attention. Goes up to the same height, comes back. Goes up to the same height, comes back. Goes up to the same height, comes back. But here, like each particle is not going to the same height, as I said earlier also. So what happens is, if I show by my gestures, for example, if this is the shape of the string, so the result is something like this. So all the particles, they go up to their extreme position simultaneously, fall back to their mean position simultaneously, go to the negative extreme simultaneously, come back to the mean position, and this is what is happening. This is never happening because here the concept of copying is there. This goes up, comes down, goes up, comes down, goes up, comes down. Here there is simultaneously movement of the particles within two nodes. So another difference is that, like here, all the particles are in the same phase. When I am saying phase, I mean to say the state of vibration. So if this particle is passing through its mean position, then this is also passing through its mean position, and surprisingly you will find that the string is straight at an instant of time. It is a straight string. So you may be tempted to think that like there is no wave now, but that is not the case, because at this moment all the particles are just passing through their main position, and after some times we will again see a shape like this. So all the particles will be at their extreme positions, and then the bulge will become bigger and bigger, and then again it will start shrinking back, and then it will happen in the reverse direction also. So the bulge will be like this, like this, like this. This is not the case in the string, because the shape of the string goes on changing and the shape moves forward. So all the particles are in the same phase. Same phase means all of them go to their extreme position simultaneously, all of them pass through their mean position simultaneously. Of course, the energy fluctuates between kinetic and potential. So when the shape is like this, the entire energy is potential, and when the string is absolutely straight, when you feel that there is no wave, but there is actually a wave, because just after some time the shape will change. The particles are moving with maximum speed, so kinetic energy is maximum and potential energy is minimum. So to just reiterate what I have said, certain points are permanently at rest, these are called as nodes. Some points have their maximum amplitudes, are called as antinodes, and all the particles oscillate in the same phase, in the same state of vibration. Now one final thing, and then I will sum up this lecture, and we'll look into the mathematics and the equation of the standing wave in the next class. But one final thing I would like to say, which is very important, is that in a traveling wave, while there is a continuous transference of energy across the medium or the string, whatever it is, here the energy is confined between two nodes. So the energy, these are lock points, as if, so energy is confined in that region, it does not pass from one region to another. But in a traveling wave, the energy is continuously transported across the medium. This is a very, very important difference which all of you should understand. So this was enough for today. In the next class, I will show you how we get mathematically the equation of a standing wave, and how will we explain the presence of these nodes and antinodes and other points which have lesser amplitudes than the amplitudes at the points of antinodes. So much for now. Thank you very much for listening, and I'll catch you later with another lecture on physics.